Hello everyone, I'm Teacher Michelle and welcome to another episode of Unang Math. In this episode, our lesson is about properties of equality. We already studied what equations are. And in an equation, the most important thing is to find the value of the variable. In our previous episodes, I already showed and explained how to substitute the value of the variable in an equation. But if the equation is long and complicated, it will be difficult to find the value of the variable. So in this episode, I will be showing you how to find the value of the variable without substituting. We will use the properties of equality in finding the value of the variable. Okay, let's start. We have here an equation 3x plus 2 equals negative 4. If we will use substitution, variable x or the value of variable x must be negative 2. So 3 times negative 2 is negative 6. Negative 6 plus 2 is negative 4. So negative 4 is equal to negative 4. That is, we use substitution. But since our focus this episode is properties of equality, okay, we have to think this way. In an equation, equal sign means the number or expression on the left side is equal to the number or expression on the right side. Or we can think this way. If I added 2 on the left side of this equation, I should add 2 on the right side of the equation. Adding the same numbers to both sides of the equation is the first property of equality. So what is the first property of equality? If A is equal to B, A plus C is equal to B plus C. That means if we added C on the left side of the equation, I have to add C on the right side of the equation to keep the equation equal. In short, what I did on the left side, I should do it also on the right side of the equation. So the equality holds even when the same number is added to both sides of the equation. So that is the first property of equality. Okay, let's move on to the second property of equality. If A is equal to B, A minus C is equal to B minus C. So if I subtracted C on the left side of the equation, I should subtract C on the right side of the equation. So the equality holds even when the same number is subtracted from both sides of the equation. Okay, let's move on. The third property of equality states that if A is equal to B, A times C is equal to B times C. I multiplied C on the left side of the equation. I should multiply C on the right side of the equation also. So the equality holds even when the same number is multiplied to both sides of the equation. You just have to remember what you did on the left side. You have to do it also on the right side. Okay, the last property of equality states that if A is equal to B, A over C is equal to B over C. So it means if we divided C on the left side of the equation, we have to do it also on the right side of the equation, provided that C must not be equal to 0. Okay, the equality holds even when the same non-zero number is divided to both sides of the equation. Okay, I'll repeat. The denominator or the divisor must be a non-zero number. If this is 0, okay, this is incorrect. We cannot divide by 0. Okay, to explain this further, let's take a look at this one. A is equal to B. AC is equal to BC. AC means A times C. BC is B times C. A is equal to B. So A is equal to B. If we multiplied C on the left side of the equation, we have to do it also on the right side of the equation. So this is correct. Okay, what about AC is equal to BC? A is equal to B. Okay, let's say value of A is 1. B is 2 and C is 0. AC means A times C. So 1 times 0. This is 0. How about BC? B times C. So 2 times 0. So this is also 0. So 0 is equal to 0. But A, which is 1, B is 2. 1 is not equal to 2. That's why C is not equal to 0, or C must not be equal to 0 to keep the equation true or equal. Okay, let's give more examples. When A is equal to B, insert the appropriate numbers inside the box to make the following equations true. Okay, the first equation is A plus 2 is equal to B plus, what's the number? Okay, A is equal to B. So this is plus 2. That means we need to add 2 on this right side of the equation also to make the equation true. Okay, let's have number 2. A minus blank is equal to B minus 7. So A is equal to B. This is minus 7. So here must be minus 7 also. Okay, number 3, negative 5A is equal to blank B. A is equal to B. If we multiply negative 5 to A, we have to do it also on this side. So this is negative 5B. Okay, how about the last one here? A over 6 is equal to B over 6. We divided 6 on the left side of this equation. We have to do it also on this side. So this is B over 6. Okay, more examples. When A is equal to B, which of the following is correct? Okay, so we have 5 equations here. We will find out which among these 5 equations is correct. Okay, let's have number 1. A is equal to B. So A is equal to B. This is minus 2, but this is plus 2. So that means equation, or the first equation, is not correct. How about the second equation? 2A plus 3 is equal to 2 plus 3B. Okay, A is equal to B. This is 2, but this is 3. So that means this second equation is also not correct. How about this third equation? A over 2 minus 3 is equal to B over 2 minus 3. Remember, A is equal to B. So A is equal to B. If we divide 2 to this side, we have to do this one also on this side. So 2 divided by 2, this is divided by 2. If we subtracted 3 from this side, we have to do it also on this side. So minus 3, this is also minus 3. So that means this third equation is true or correct. Okay, let's check this fourth equation. 1 minus A over 3 is equal to 1 minus B over 3. 1 minus B over 3 is equal to 1 over 3 minus B over 3. So 1 over 3 minus B over 3. A is equal to B. Okay, this is 3. This is also 3. So minus A over 3. This is minus B over 3. But this is 1/3 and this is 1. So that means number 4 equation is not correct. Okay, how about this last equation? 3 over 2A plus 1 is equal to 2 over 3B plus 1. A is equal to B. This is 3 over 2, but this is 2 over 3. So that means number 5 equation is incorrect. Okay, this time, let's answer this simple activity here. So which of the following is not correct? So we have 5 options here. So let's find out which is not correct. Okay, the first option is when x is equal to y. So x is equal to y. This is minus 5. This is also minus 5. So letter A, or the first option, is correct. Okay, how about letter B? When x is equal to y. 3 minus x over 2 is equal to 6 minus y over 2. 6 minus y over 2 is 6 over 2 minus y over 2. So let's rewrite 6 over 2 minus y over 2. We can simplify 6 over 2. This is equal to 3. So we have 3 minus y over 2. Okay, x is equal to y. So this is 2, this is also 2. Okay, minus x over 2, this is also minus y over 2. This is 3, this is also 3. So that means this equation is true or correct. Let's move on to letter C. Y over 3 is equal to x over 3. 3x minus 1 is equal to 3y minus 1. Okay, we can multiply 3 to this side and also 3 to this side. So 3 will be cancelled. So y is equal to x, or x is equal to y. Okay, this is x, y. This is 3, 3. This is negative 1. This is also negative 1. So that means equation C is correct. Okay, how about D? When 2x is equal to 2y, 5 minus x is equal to 5 minus y. Okay, we can divide both sides by 2. 2 will be cancelled. So x is equal to y. Okay, this is minus x. This is minus y. It's correct. This is 5 and this is also 5. It's the same and it's correct. So that means letter D is correct, or this equation is correct. Okay, now let's check this last equation here. X is equal to y. X over 2 plus y is equal to y plus 2, y plus 1 over 2. Y plus 1 over 2 is equal to y over 2 plus 1 half. So y over 2 plus 1 half. Okay, x is equal to y. This is 2, this is also 2. But this is 1 and this is 1 half. So that means equation E is not correct. So which of the following is not correct? Equation E is not correct. Okay, let's continue with this next activity. When A is equal to 2B, select all the correct equations. Okay, remember A is equal to 2B. Okay, let's check this first option. A plus 4 is equal to B plus 4. Okay, A is equal to 2B, but this is just B. So that means first option is not correct. Okay, how about letter B? Negative 2A is equal to negative 4B. Okay, if we multiply negative 2 on this side of the equation, so this is times negative 2, we have to do it also on the right side of the equation. So this is negative, or times negative 2. So 2 times negative 2 is negative 4. So negative 2a is equal to negative 4b. This equation is correct. Okay, how about letter C? A plus 6 is equal to 2 times b plus 3. Okay, we have to remove this parenthesis so we can compare properly. And we can do that using distributive property. So 2 times b is 2b plus 2 times 3 is 6. So 2b plus 6. So A is equal to 2b. So it's correct. This is plus 6. This is also plus 6. So letter C equation is true or correct. Okay, how about letter D? Negative 3a plus 2 is equal to negative 6b plus 4. Okay, if we multiply negative 3 to a, we have to multiply negative 3 on this side also. So 2 times negative 3 is negative 6. So negative 3a is equal to negative 6b. But this is 2 and this is 4. So that means equation D is not correct. Okay, let's check this equation E. A over 4 minus 4 is equal to B over 2 minus 4. Okay, A is equal to 2B. So if we divided 4 on this side, we have to do it also on the right side. Okay, so A over 4 is equal to 2B over 4. But we can simplify 2 over 4. So this is 1/2. So A over 4 is equal to B over 2. So A over 4 is equal to B over 2. This is minus 4. This is also minus 4. So that means equation E is correct. Okay, let's move on to this last equation. 5 times A plus 2 is equal to 10 times B plus 2. Okay, we have to remove this parenthesis so we can compare easily. We can do that using distributive property. So 5 times A is 5A plus 5 times 2 is 10. So equals 10 times B is 10B. 10 times 2 is 20. So plus 20. Okay, remember A is equal to 2B. Okay, if we multiply 5 by A, so this is times 5, we have to do it also this side, so times 5. So 2B times 5 is 10B. So 5A is equal to 10B. It's correct. But this 10 is not equal to 20. So that means equation F is not correct. Okay, this activity is a very good activity in identifying if the equation is true or not. Okay, you may answer it again and you can share your answer in the comment section.